Welcome to the MSJC Internet Authoring Videocast.
Welcome to CSIS 113B, Lecture 8, covering arrays and parameters. In this lecture, we'll talk about arrays in some depth. We'll take a look at what is an array, declaring arrays, accessing arrays and how they're stored in memory, initializing arrays at declaration, how to use for loops with arrays, filling and parsing arrays, arguments and parameters. We'll talk about using constants as arguments, also passing reference types versus value types. And we'll show you how to use arrays as arguments for passing two methods. We'll talk a little bit about the array length property, and then also we'll introduce you to multi-dimensional arrays. So what is an array? Well, you can consider it to be a contiguous group of homogeneous elements. So contiguous, meaning that they all sit next to each other in memory, and homogeneous, meaning that they're all of the same data type. So an array can only contain integers or doubles or floats. You can't mix the different types within a single array. It might be easier for you to think of an array as a series or a collection or a list of like data value types that can be accessed using one name. A single name can be used to reference a collection of these various data types. And so, for example, you might have a collection of grades or scores or temperatures. So you'd have multiple values stored in a single array, and then you can reference that array by this one name. This is our first aggregate type, and you'll hear it referred to often as collections, also another category that's used to reference these types of data types. There's various types of collections like lists and dictionaries. An array is just another type of a collection. So another way to think of it then is as a collection of data values that makes a new data type. So you've been introduced to the primitives, integers and floats and doubles and chars and booleans, and we can have those all in a collection, which then at that point becomes a new data type. So here's a depiction of an array. The first blue box there, we're declaring the array. So you can see that when we do that, we have to identify the data type that we're going to store in the array, followed by two square brackets. So the square brackets indicates that what we're trying to create is an array, and then the int before it says it's going to be an array of integers. Then that's followed by its name, which in this case, this example, it's my array. So three important pieces there. You have the data type, you have the symbol for array, and then you have the name of the array. Then we use the assignment operator, and then the keyword new in this particular example, and that's followed again by the data type that we're storing in the array. And this time the square brackets there is used to represent how many elements we want to have created in this array. So that declaration is going to create a new array that will be able to contain integers only, and it'll be named my array. So if you look underneath now that declaration, you can see sort of a pictorial example of what we're creating in memory. So if you think about what we've talked about previously, how variables represent a named box, a storage area to put a value into. Well, in an array, we can store multiple values. And so each one of those boxes is referred to as an element. And each one of those boxes in this example would be able to store a single integer value. Now you'll see too later on, as we go to reference the values that are stored in the array, we will refer to the index number of where that value is stored. And it's important to understand that these index values for arrays always begin at 0. So if you're looking closely at that diagram, you'll notice the first box has index 0, followed by the next index value of 1, and then 2, and then 3, and then 4. So that's the index number that's representing each of those elements. So we have 5 elements, and the index number starts at 0 and ends at 4. So the last index value in any array will always be 1 less than the total number of elements in the array. So as I mentioned before, when we want to go to actually take the values, refer to the values that are stored in the array. We'll do so using the index number, many times also referred to as a subscript. And so the bullet there that you see, we're using the system.out.println method. And then in the parentheses, we identify the name of the array and then the particular box that we want to grab the value from using its index number. So in this case, we want to find the value that's stored at the third index in the score array. Now remember that since we're starting at 0, another way to refer to that would be that we're getting the value from the fourth element in the array named score. Now, when you don't have a lot of experience with arrays, it may be kind of confusing for you at first. There is two uses for the square brackets. So in the previous example, when we were declaring the array, we were identifying how many boxes, how many elements we wanted to create in that new array. In the example we're using here on this slide, we're still using the square brackets after the name of the array, but in this case, we're representing the index, the actual box that we want to retrieve the value from, the actual element that we want to retrieve the value from. So it just kind of depends on how you're using it. So in declarations, it'll specify the size of the array, but then pretty much everywhere else in your program, it'll specify the index value of the element. And by the way, when we're creating the size or referencing the index subscripts, they don't have to be actually literal values. We can use things like constants. So constants is just a type of variable that once you assign a value to it, it never changes. So you can see in the example here, we're using max_scores as the value when we identify the new size of this new array. So an int array that's going to be named score, and then we're passing to it this constant, which is a value or a variable that's stored already, has a value stored in it, and that's determining then the size of the new score array of integers. Another example, if we're referencing a particular index or subscript value, we can type in the name of the array. In this case, it's score, but in the square brackets, that's the important part. You can see there we're using a variable n, and then actually we've got a mathematical expression in there, right? We're incrementing n by a value of 1. So if n starts out as a value of 2, then that value, that expression inside of those square brackets is actually now the value of 3 because we're adding 1 to n's original value of 2. So that would be the same as writing score in square brackets 3. So again, another visual representation here of an array. In this case, we're creating an array named myArray. It's going to hold integers. So we're using those three components we talked about before, the data type, followed by the square brackets to indicate we want to have an array, and then the name of the array, which is myArray. And then to the right of the assignment operator, the new keyword, followed again by the type, the data type that we're storing in the array, and then since this is a declaration, we're actually defining how many elements are being created in the array. Now, for this depiction, underneath of that now, you'll see that we're actually assigning a value into myArray. So at index 1 of myArray, we want to assign the literal value 7. And so graphically then in the blue box at the bottom, that's what we're representing. The value, the literal value 7, has been stored at element which is indexed as 1. So notice that that's the second element. Again, just because we're starting at 0, it's the second element. Its index value is 1. In this slide, we're depicting how arrays are stored in memory. So here what we're doing is we've already created this array called myArray. It has 5 elements. The indices start at 0 and go through 4. And then in the statement below the blue box, you can see that we're assigning to index 2 in the array the value of 6. Remember back to our early definition of arrays, we talked about the fact that arrays are stored in contiguous areas of memory. So that means that each of the boxes depicted here as you can see, are in sequence as far as their memory location goes. So since we're storing integers in here, then that means we need to have 4 bytes of space in memory for each of those integers. So in this particular example, the beginning address of the array happens to be at 500. Then the second value is stored at 504, the third value at 508, the fourth value at 50C, this is all hexadecimal, and then the fifth value, the fifth element, is at 510. And don't worry about that if you're not familiar with the hexadecimal addressing. Just realize that is a sequence incrementing by 4 bytes each. So when we say that we want to get the value in my array at index 2, that's the same thing as saying the address of my array, because the my array itself, what's being stored on the stack for my array, is the actual beginning address of the array. So that's at 500, 500. We're trying to access the third element, index number 2, so that means that 500 plus 8 bytes is where the Java virtual machine will attempt to locate the value that we want to retrieve from there. Here we're talking now about initializing the array at declaration. So up until this point, you've just seen the declaration where we had the new keyword and then the size of the array identified. So in this example, you can see we're creating a double array, an array of doubles. It's going to be named D. But instead of using the new keyword and how many values we want to store in the array, we actually create the array using the literal values that we want to have stored in each location in the array. So as you see here, we've got a total of 5 values between curly braces. They are doubles, so that's why we see the decimal places in here. But the important part is notice that each individual value is being separated by a comma. So when you want to identify the literal values that you're going to store in an array, when you want to assign them to an array as you're declaring it, it goes inside the whole sequence of numbers, or the whole sequence of values, goes inside a set of curly braces, each value being separated by a comma. Then on the next line, we're just simply calling, or assigning, I should say, one of the values from our D array to a double variable which is named x. And so that means x at this point in time is going to be the value 5.5, because if you look at the third index starting with 2.2, that's 0, the next one is 1, the next one is 2, and the next one is 3. So 5 is at the index of 3 in our array D. So that value is retrieved from that location and then assigned to the variable x. Now, a common way of retrieving all of the values that are contained in an array, a common way of retrieving all of the values in an array would be to use a for loop. So you can see here in the main method, we have created a new array D, and we're assigning to it the values of 2.3, 3.3, 4.4, 5.5, and 6.6. Then we use a for loop and output each of the individual values stored in the array. So notice that when we create the for loop, we're just using integer I starting at 0 because that's where our index values begin. And we're going to run this as long as I is less than 5, because remember, the last index number in an array is always going to be 1 less than the number of elements in the array. So as long as you identify the condition as I being less than the length of the array, then no errors will occur as you parse through the for loop. And the last item, of course, is we're incrementing I each time through the loop. So I is going to start at 0, and that means we're going to get D0, index 0 value first, have that printed to the screen, and then it increments the I. So we'll show you then how this prints out all the values in the array. We'll give you kind of an animated example coming up here in just a bit. On this slide, we're just reiterating what we just talked about here. So for loops work well with parsing arrays. The example we have here is, again, just printing out the contents of a score array. And the key is that our control variable, I, is going to be counting from 0 to 4. So it starts out as 0, and the conditional expression says continue to run the for loop as long as it's less than 5. So 4 will be as high as I gets. So we'll show you this now in a little animation. So this is similar to what we've been looking at. We've got this array double, and it's named D, and it has, in this case, 4 values stored in it. Then we're going to use a for loop starting I at 0, and since we have 4 elements, we want to use I lesser than 4, and then increment I each time through the loop. So the first thing is that the double D array is initialized and stored on the heap. Now we go into the for loop. We initialize our control variable I to 0. And if you look in the top left-hand corner now, we're going to keep track of the values of I as we go through here. Then the for loop checks to see if I is less than 4, and it is. So we go ahead and we print out then the 0 element of our D array. Now we increment I, so I now is the value of 1. We check again in the for loop to see that I is less than 4. It is. And so we're printing now D's first, I shouldn't say first element, index value 1 element, which is the second element in the array. So 3.3 now is being printed to the screen. Again, we increment I. Now it's at 2. Checking again to see if I is less than 4, and it is. So now we want to print out D at index 2, which is the value 4.4. Increment I again. Now I is 3. Check to see if I is less than 4. It is. So once again, we print out the array D at index 3 this time, which is the last element there in the array, 5.5. And now we check to see, or we increment I one more time, and then we check to see if it's less than 4. It is not, so we escape the for loop, and we print to the screen, end of loop. So I hope that illustrates for you, makes things a little clearer for you as far as how arrays work with regards to for loops, because that's a common thing that you'll be doing. So some of the pitfalls that you might run into as far as arrays are concerned, and we've emphasized this quite a bit, so I hope that you've got it already, but array indexes always start with 0. That's just the way that works in the world of computers. The lowest value usually is going to be 0 because we're using the binary numbering system. And now if we exceed the total length of an array, then the Java virtual machine is going to throw an error which is called an array index out of bounds exception error. So it's up to you, the programmer, to stay within the range of your array's length. And fortunately, we have a length property that is part of the array object. And so we'll show you how to use that to help you out when you're parsing through your array. So here's an example then of getting that array error we were just talking about. If you write code that actually references an out-of-bound index value, meaning an index value that does not exist in your array. So if you have an array that's named temperature, subtype double, which is inconsequential here, the main thing is we're creating an array of temperature that's going to be 24 elements long. So that means that the range of indexes is only going to be 0 to 23. So the common mistake is making a reference to your temperature array and calling index 24, and in this case attempting to assign a value of 5 to it. But that's an out-of-range location in the array. So that's when that runtime exception is thrown. We mentioned this a little bit earlier that you can use constants for your array size. It's a good idea to use a named constant for it, for the size of your array. So in this example, just showing you how to create a constant. So static final int number of students and then assigning the value of 5 to it. So static just allows us to use it without creating an instance of the class. Final is the key word that says that this variable cannot be modified. Then int, you're familiar with that. We're just saying it's a variable of type int. And you'll notice too that constants, and this is a common way of naming constants, which is to have them all uppercase And if it's multiple words, put an underscore between each of the words. That makes it easy to see in a program where a constant value is being used. So then here's an example where we're creating an int array called score, and we're using the new keyword to the right of the assignment operator, and then using the int to define that we want to have an int array, and then for the size of that array, we're using that constant number of students. So the reasons that this is a good idea is it improves readability, versatility, maintainability of your code. So you can use defined constants anywhere that you have a size value that you want to have in your array. And the advantage you're going to see here is that we only need to change the value of the size in one place. So as long as you use this constant everywhere you use the array, then you won't have to go through your code someday and make changes to the size several different places in your code. So here we've got an example where we're using a for loop, and we're using for the conditional statement I less than, and then that constant number of students. Now remember that number of students is the number of elements in the array. So if you ever want to reference the size, it's important that you remember that you need to subtract 1 from whatever the constant value is that you're using for size there. So the example we use here is just last index equals number of students minus 1. So that would be the correct ending index value within an array. So this could be helpful when passing arrays to a function. We'll look at that a little bit later on. And then the important thing here is, again, if the size of the array changes, you only have to change one location in your program. So if we need to have a bigger array, we started out with an array of 5, and for some reason now it needs to be 10, you just have to go into the code and assign the value 10 now to that defined constant. As long as you used it everywhere else in your program, then that will update that throughout the program. So here's an example of both creating values in an array as well as going through and printing the values in an array using for loops. So we start out with an integer array of size 20, and then we're going to populate it as we create the values, the elements in our array here. We're going to use a random number generator. So in the for loop, again, we're using array less than array dot length, because length is the property that defines how many elements are in the array. So as long as we use that less than operator, we'll be good. And so as we go through the for loop, you can see that array and then in square brackets I, so whatever the current value of I is, will be the current index that we're targeting when we assign the random number using the next int method there on the right. Then same thing for printing the array back out again. You can see that the for loop header is exactly the same as it was up above there. So the key being that we start I at 0, and then the condition I less than array dot length. So that means that it's just going to go through now. Each time that we call the array, we're going to have a different value for I, starting from 0, going up to 19, and it'll output then each of the elements in order. So if you think about how we've been referencing the contents of our array, we've been using the index value, so you can refer to that then as an index variable. And you use it the same way as you would your simple variables. So in the example there, you can see that we're creating a new method called myMethod, and it's going to accept a parameter of type double. And it'll be using the name param1 internally. But the important thing here is that it's accepting a parameter. It's of type double. So when we look at the declarations that you see there in the next line, we're creating an integer named I, creating a double named n, and then we're creating a new double array which will have 10 elements, and we're calling that A. And we can pass any of those 3's into myMethod. So if you pass I into myMethod, since it started out as an integer, but we're expecting a double there in myMethod, it can be converted to a double. I can be converted to a double. In the second call to myMethod, now we're passing to it our indexed variable. So in other words, we're calling the A array at index 3. And since that array already contains double, there's no conversion that's necessary there, so that passes just fine. It's accepted by our my method without a problem. And then the same thing with n. N is also a double, and so when it's passed into the method, there's no problem as far as processing that. Now, when we're talking about passing parameters to our methods, there's two types. You have your value types, which are the primitives like ints, chars, doubles, floats, booleans, etc. And then we also have reference types, which are complex types like classes and like arrays. So yes, an array is a complex type. Remember that the actual data for the array is always going to be stored on the heap, whereas with the primitives that we talked about in previous lessons, previous lectures, the value types there are always stored on the stack. Now for the last bullet point there, it does say that we need to use the new operator to create instances on the heap. Just realize that's not absolutely true, because if you think about it with our arrays, which the values always get stored on the heap, we don't necessarily have to use the new operator, because we could just simply assign literals to the new array when we declare it. So you don't always have to use the new operator, but if you're not assigning literal values to it when you're declaring it, then you will have to use the new operator. So random, which you've used several times, is also a complex type. It's a class, right? You should know that random's a class by now. And so that means that its values all get stored on the heap. So when we create an instance of our random object, like here, RND is the instance of our random object, all of its values are actually being, the class, the content that makes up random is actually being stored on the heap. And the variable RND actually has a memory reference to that random class where it's stored on the heap. Now in this particular example, notice we didn't use the new operator, so we didn't do random RND equals new random. So we're declaring RND at this point, so it has a memory address at this point, but the value that's stored in there, because there's no real instance created yet, because we haven't used the new keyword, the value that's being stored for that variable RND is actually null. And that graphical symbol you see there, that's the ground symbol that's typically used to represent the value of null. Now we're actually using the new keyword, and so ran gets assigned an address. So if you look at the blue box, there's actually two addresses there. So the 500 is where the rand value is being stored on the stack. The rand value that's being stored on the stack is the address in the heap where that random, the instance of the random class is being created. So all of the code that makes up the class random now is stored on the heap at A0000. But in order for the program to reference it, it needs to put a value onto the stack, and the value is what we call a reference value. The reason it's called a reference value is because we're referencing the memory location where it's being stored on the heap. So when we use RND within the program, we're actually getting that reference, that memory address from that's where the rand instance is being stored on the heap. So when we're passing our reference types to a method, what's getting passed is a copy of the address where the object is located on the heap. You can see that here in the example code on the right, where we've got a method print double, and its parameter is of double. Now notice that's a capital D for the parameter inside of the parentheses for the print double method. So you need to know that that's not the primitive double. If you think about how we've used the primitive double up to this point, it was always lowercase d. So lowercase d double is the primitive data type. That would only store the value on the actual numeric literal value on the stack. Uppercase D for double means that you're actually using the class. There is a class in Java that is also called double, and it stores double values, but it also has some properties and methods that go along with it. So this type of double is much larger than just the literal value of a double, and it wouldn't fit on the stack. So anything that doesn't fit on the stack, we have to store it on the heap. So when we create this method, we're identifying to the Java virtual machine that we're going to expect that we'll be receiving the address on the heap of where the information for this double is actually being stored. And I should also point out here, this is an older slide that I did not update. It's in the main method there. You can see what's happening is that when we're declaring double D, so the second line in the main method, double D is equal to new double 3.5. That's actually been marked for deprecation. That means that the people that keep updating the Java language, they've said that they encourage us not to use that anymore because they're going to remove it completely from the language at some point. That's essentially what deprecation is referring to. So the proper way to do this would be to just have double D equal to the literal value 3.5. That is now the preferred method. So you can see I changed that here on this slide, because this sequence of slides here is going to give you an example of how all this works. So we've got a stack and we've got a heap here. And because in main, see the highlighted statement in main is double D equals 3.5, so that's the instance now that's being created on the heap at location A0000. Then the next line, console C equals new console, that's just simply creating an instance of our class so that we can then call this custom method up above called print double by just using this next line here, c.printDouble, and then passing to it the value of the variable that we created, D. Now if you look at the stack, you'll see that when we did this, when we passed that parameter, when we're making the call to the printDouble method and passing the parameter of D to it, what happened is the Java virtual machine now is pushing the value of D, which is, remember, a reference value, meaning the address of where the actual contents are stored in the heap. So that's why we get the A0000. That's the reference for the heap memory of where the actual literal value is being stored. Now the next thing is that the method is going to be loaded and processed. And so it takes that reference, that memory address reference, and passes it now as the parameter into that custom print double method as a variable dbl. And then in the next line, dbl is that instance itself. So now we're getting the address, we're using the address to go get the instance of our double variable that's stored on the heap, and using its toString method. So that's one of the advantages we get when we use a class is, as I said earlier, it comes with properties and methods. So in the case of a double, the class, it contains a method called toString, which is a method that converts doubles into string values. So just like earlier when we saw array had a property length, again, that comes with the fact that array is a reference type. It's actually an object or a class. It's not a primitive variable. So that's the same thing going on here. We wanted to use the method that came with the double class toString. So that's why we declared the variable that way, so that we'd have access to this method. But it's just important for you to understand that it's not a value that gets stored on the stack, it's an address, and that address points to the actual instance which is stored in heap memory. So the reason we showed you the double is so that we can come back and talk about arrays, and when we use arrays as arguments, we've got the same thing going on because arrays are also complex or reference types. So every time we want to pass an array, we're passing it by reference. In other words, the address of the array. And you have to remember, too, that when we pass the memory address of an array, it's the address of the first element in the array. And then from there, the Java virtual machine can figure out how to locate the values for the rest of the elements in the array. As we talked about it earlier, an array of type ints is going to be spaced out by 4 bytes each. So here's a good example of how reference types can be used within a program. I highly encourage you to write this code out and run it to see how it works for yourself. But let me explain it to you. We can see that we've got this custom method called fillArray, and it's going to take in an array. It generates a new random object, r, and then in the for loop, we use r to generate a random number and assign it into the array that was passed into this custom method. Now, if we jump down to the main method, you'll see that we have this myArray, which is going to be a collection of integers, and it's going to be of size 20. Then we instantiate a new console, so our class is named console, and we're going to call it C, so that we can utilize our fillArray method here. So we just use C dot and then the name of the custom array and then pass to it myArray. So remember, that's a reference type, meaning it's the address of where that myArray is stored on the heap. So the interesting thing about that is when we pass then this array object into our fillArray method, and the random number generator in the for loop assigns 20 different randomly generated values into that array, notice that this method doesn't return a value, right? It's void in the header there, which means we're not going to return anything. But because when it takes in the array as a parameter there in the parentheses for the fillArray method, again, it's just taking the address. The address is pointing to where that actual object is on the heap. So when we run the for loop, we're actually modifying the object then that's on the heap. So then when we come back to our main method, you can see we have a for loop here where we run through the myArray, and when you print that out to the screen, you will see that there will be 20 randomly generated numbers in that array. So myArray in main points to the same address on the heap that the custom method's parameter AR is pointing to. So that's what allows fillArray, the custom method fillArray, to modify the actual original myArray that we created there down in the main. So there's no need to pass it back out of our method. But don't take my word for it. Like I said, write that code out yourself and run it, and you'll see that that's exactly the case. And then hopefully that helps you to better understand what we're talking about here when we are storing instances of our objects on the heap. So if the address points to the same location on the heap and you're modifying things at that address, then anything that points to that address will see the modifications that are being made to that object. So here's a visual depiction of that. So when we in main created myArray, a new location on the heap was created for that array. It was assigned an address. And when we then pass myArray as a parameter into a custom method, in this case fillArray, it's just the address that's being passed in as the parameter. So that custom method now is using that same address on the heap, so any modifications that it's making to the array is made to the original myArray. So you saw this briefly a little bit ago, that the length property is a valuable property for arrays because it allows us to easily and quickly identify how many elements are in that array. Short bit of code here where we create the array and then just output what the length of the array is, and the output here will generate 20 because that's how many elements we created in that array. You have to remember, though, that the number of elements is always one more than the last index. And so now we're using that in the for loop example here. And as I've pointed out several times, the key is in our for loop, the conditional statement, I is less than our arrays dot length. As long as you use that as your conditional, you'll be fine. You will not extend beyond the range of your array. Now, previously in the last slides there, we were talking about how we don't really need to return arrays, but we can return an array from a custom method. And so this is an example of that. And just keep in mind what's being returned is the address of the array itself. So in this case, it's a custom array that actually creates the array internally, and what's passed to it as a parameter is the size value. So that way we can use a custom method and create arrays of varying size. So again, we're just using a random number generator to assign the values that are going to be stored in the array. Notice when we declare the array here, it's going to be of int type, it's going to be named A, and then again we use the new keyword and then int, but in the square brackets, instead of an actual value, now we're using that size parameter. So that's what gives us the flexibility to create arrays of any size in this method. Then when we go to parse fill the array, we use the for loop, and we're using I as our control variable, and we want to run this as long as I is less than A's length, the length of the array. And then each time through we increment I, so I, or A in brackets I, is going to start at 0. We're going to assign a random number to it. You know how this works, going up until 1 less than our length. So we are filling the array with randomly generated numbers. And then the last line is that we're returning the array. And I should point out in the header here of our custom method, notice now that it's not public void, but it's public and then the type of array that's going to be returned. So this is going to be an array of integers that'll be returned from this particular method. So it's important to remember that when you return an array from a custom method, you will need to create a reference in your main method to assign the address of the array that you're returning back to it. And so that's what we're seeing in this example here, where we have a new integer array called myArray that is created in main. And then on the next line there, we actually initialize it by running the custom method createArray and passing the size value 20 to it. So a 20 element array will be returned from createArray, and that's now being assigned in main to the instance of myArray. And then the last line is just printing out the contents of that myArray that was generated here in main. Now we look at multi-dimensional arrays. So arrays can come in just about as many dimensions as you would like. However, going beyond 2 dimensions is not really recommended. So the common array type, multi-dimensional array type, is going to be 2-dimensional. And just think of it like a grid, like a bingo card, or if you've ever seen an Excel spreadsheet, you've got a table in there. So it consists of rows and columns. So if you declare a 2-dimensional array, it's done the same way as a single-dimensional array. You just add another set of square brackets. So you can see in the last bulleted item there is the example, where again can only store a single data type. So it's a homogeneous unit, just like a single-dimensional array. So we're identifying int as the type of data that we're going to store in this 2-dimensional array, and then we just have 2 sets of square brackets. We name it myArray, and then to the right of the assignment operator using the new keyword and then int, and then in this case we're identifying how many rows in the first square bracket and how many columns in the second square bracket. And since we haven't really assigned any values in there, the array gets created as you see in the table graphic below, and all of the cells contain the value 0 because that's the default for integer types. So the key really to 2-dimensional arrays is just remembering that the first set of brackets is always representing the rows, the second brackets always representing the columns. So in the example we have on this screen here, we're just assigning a value of 3 to my array in row 1, column 2. 2D arrays are contiguous in memory, so that means that they're not organized like as a table in memory. It's just one long string of addresses that points to each of the elements in each of the rows. In this example, we are actually initializing, so assigning literal values now into our two-dimensional array. The critical thing here is just remember that you need to have two sets of curly braces. So you need an outer set that defines the outer bounds of the array, and then internally you'll group each row of values into its own set of curly braces, and notice each set of curly braces there divided or separated by a comma. So you need to have one set of curly braces around the entire array, and then for each of the rows another set of curly braces. In the first row we're going to have the values of 1, 2, and 3, so those values separated by a comma, and then after the closing curly brace for the first row you have another comma to designate now we're beginning a new row, and that's going to consist of the values 4, 5, 6, another comma outside of that curly brace, and then the final row, the third row, contains 7, 8, 9. So the values inside of those curly braces are representing the values in the columns. The curly brace sets themselves each are a row. So in this example of our AR array, we're trying to retrieve row 1, column 2. So row 1, remember, is the second row because your rows begin at 0. So that means that we're in the grouping 4, 5, and 6, and we want to get the index 2 elements. So that's, since each of these rows contains 3 elements, that means that index value 2 is the last element in each of the rows. So when we go to row 2, which is indicated by index 1, and then the last element in row 2, which is indicated by index 2, it's the value 6 then that's being assigned to our variable x. Now it gets a little bit trickier when we want to fill and parse our two-dimensional arrays, but here's a good simple example for you. You can see that the trick is that we're going to use nested for loops. So the outer for loop is going to represent the number of rows, and then the internal for loop will parse through each column value within the current row. So the outer loop, you're using ar.length in the conditional portion of the for loop because that's the overall size of each row. But look in the nested loop there, we use AR0 in length. So what we're saying is what's the length of the first row? That's going to be how many columns are in each row. So the outer loop, just use your array name dot length. That'll take care of how many rows that there are. And then in the inner loop, you could do one of two things here. We'll show you in another slide that you can apply a variable in here, but for now just visually realize that the first row, as long as your two-dimensional array has the same number of columns in it, which it should for every row, then you just pick the first row and check its length. So here's another way of doing that that kind of makes it, I think, a little bit easier to understand, which is that instead of using I now for our control variable, we're going to use row and column for the control variables. So that makes it easier to keep track of what we're dealing with. So you can see the outer for loop, we've got int row equal to 0, and we're going to run as long as row is less than ar.length, and then increment row each time through the outer for loop. Now in the nested for loop, we're going to use call as our control value. It is also starting at 0. We're going to run call as long as we're less than AR0, but what you can do, because you've established the control variable row in the outer loop, you can replace the 0 with the variable row. That way, it actually, if you had a variable length two-dimensional array, it would be able to keep track of what the actual length is of the row that it's working on in the internal for loop, in the nested for loop there. In fact, a better example of it is inside the nested for loop. When we actually print it to the screen, you can see that we're just using AR and then row inside of the first brackets and col inside of the second brackets, so that we're actually grabbing the specific row and column and the value for that row and column to display to the screen. So just like a 1D array, we're passing the address of the 2D array around as we're using it for parameters and whatnot. So in this example here, we've got the create array custom method is going to return a two-dimensional array, and it takes in two values. One's going to represent the row size and the other's going to represent the column size. So we use the R size and the C size when we're declaring the new integer array, two-dimensional array, that's going to be named AR. It's going to be equal to new, int, and then R size, C size. R size in the first brackets for row, C size in the second brackets for column. Then we just go through a nested for loop using a random number generator and assigning a random number as we go through, and again using the keywords row and column here as the control values, and then using those control values, if you look at again inside of the nested for loop, we've got row and column there, that whatever the current row is, current column is being assigned a randomly generated value. Then we return AR back to the caller, so if we jump down to main, of course that's where we're calling it from. So in this example, we're creating a 5x5 2D array. And though that array is created, then in the create array custom method, return back to main, assigned there to the AR. So if you look at the first line in main, you'll see that that's where we actually declared AR, integer, two square brackets, AR, semicolon. And then 2 lines down, we're assigning the results of running the create array and giving it the two size values, 5 and 5. And then again, we've got a custom method and it prints out that 2D array. So I know this was a pretty heavy-duty lecture. We looked at what is an array, which it's a collection then of values. We showed you how to declare arrays, access them. We talked about how arrays are located in the heap memory. We talked a little bit about initializing arrays at declaration, so that was when we were assigning the literals directly into the array as we created it or declared it. We showed you how for loops are used with arrays, so that's a very common practice, as you could see throughout. In fact, we used that when we were filling our arrays and parsing our arrays as well. Then we got into arguments and parameters, and the main thing there was to make sure you understand the difference between reference types and value types. So when you're changing values on the stack, which are a value type, those are all local to the class that you're running. But we're using arrays, which are reference type. You're actually passing the address around, and the address then is always the same for a particular array, and so you can use that for manipulating it inside of custom methods should you need to. And you don't necessarily need to pass it back, since you're actually changing the original array when you do that. So we showed you how to use arrays as arguments. We talked about the length property, which is very helpful to use in your for loops. And then we showed you how to create multi-dimensional arrays as well. And we said it's best to not exceed a two-dimensional array. So I encourage you to work on the guided practices. That'll help you really to understand these concepts a lot better. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.